IT Service Delivery and Support Part 3. As an auditor, you really almost have to be a jack of all trades, master of some. I didn't say master of none. I didn't say master of all. I said master of some. And as we find out, some auditors just aren't that strong in the area of networking technology and security. So this is one of those domains of the CISA exam that you might want to supplement your training, not because you need to for the exam objectives coverage, but just in case networking technology is not your bag. So if you have any extra funds in your training budget, you might want to check out the Network Plus CBT Nugget series as a precursor to this particular Nugget movie, just in case you're new to the networking arena. Now, if that's not the case, then you're good to go. And that being said, we're going to now explore information systems network infrastructure. IT Service Delivery and Support Part 3, or Information Systems Network Infrastructure. In this nugget, we'll take a look at 5 key areas. We'll look at different network infrastructure taxonomies or classifications. Then, all along the way, we're going to apply these techniques and these systems to the OSI 7-layer model. We'll talk about local area networks and wide area networks and their accompanying technology. We'll look at virtual private networks, and we'll finish up looking at wireless networking. You know, technology is so readily available nowadays that kids that are growing up are pretty much inundated and overwhelmed with different types of communications. But when I was a kid, you know, to get a set of walkie-talkies for Christmas was like, I mean, you were living in sci-fi land. And walkie-talkies for me was kind of my first introduction to that basic baseband half duplex communication where we're on a single channel with 2 parties and only one of us could talk at a time. Now, of course, I was familiar with full duplex communication where 2 parties could speak simultaneously because, of course, we had telephones. And then I had a friend down the street who had a ham radio set up, so I got some communication technology that way, some shortwave radio stuff. But, you know, I'm an old-timer. Well, we want to understand 2 major categories here of communication. First of all, you have baseband technology, which is really what we're kind of used to with the telephone and 2-way radios and walkie-talkies and using the computer at your company, okay? This is basically Ethernet technology now, where data is sent over a single channel on a single medium or a single wire. Now that's opposed to broadband, and broadband's a very hip term that we hear used in all different kinds of circles, but broadband carries several channels at one time. And that's why you hear things like broadband referred to as cable, because you have cable piped into your home, and on the same line you'll have several channels. Channels for TV, channels for ordering movies upstream, channels for your telephone, channels for your internet. Again, cable TV, a prime example. So it's important to understand right off the bat that there's 2 kind of, in the first taxonomy that we're talking about here, there's these 2 general categories, baseband and broadband technology. Another major taxonomy or classification you need to know about are the different types of networks, and the CISA breaks these down into different ANs, different area networks, LANs, WANs, MANs, SANs, and PANs. A LAN is a local area network, a WAN is a wide area network, a MAN is a metropolitan area network, a SAN is a storage area network, and a PAN is a personal area network. Not a personal pan pizza, but a personal area network. Now, a local area network is a computer network that basically has a small geographic area as the coverage, a small office, a home office, maybe a small campus, a group of buildings. Now, local area networks can be wired, typically with 802.3 Ethernet wiring running at 10, 100, or 1,000 megabits per second, or they could be a wireless local area network. So that would be what we call a WLAN, a wireless LAN. Now here's my crude little drawing. A typical local area network in a small office or a small to medium-sized business would typically have some type of high-speed connection to the global internet, the untrusted public internet. They also may have other connections to partners, vendors, customers. That's called an extranet Then they'll have on this, and this is their perimeter device, which could be a firewall, appliance, or a perimeter router that has one of the interfaces going to what we call a DMZ security zone. And here you'll have servers like web servers, FTP servers doing the FTP protocol, maybe email servers that are servicing requests coming from the internet. Typically on your local area network here, these users won't access this DMZ. If they do, it's done very carefully. Then this firewall will connect to an interior router or multi-layer switch, that's MLS. A multi-layer switch, something with some type of routing processing that can route between this internal local area network and external networks and the DMZ, things like that. And this will connect to other buildings perhaps, other areas of the campus, other departments, whatever. But the local area network we're concerned with here is this access switch with a bunch of switch ports on it, and we're connecting servers, and maybe you've got telephony, phones that are connecting through some type of wireless connectivity, maybe going to this wireless access point here. You've got printers, you've got workstations, you've got PCs, you've got, this is going to be a laptop here. You've got laptops. So pardon my Fred Flintstone school of art here, but this is a local area network, okay? Typically, each node that we're looking at here has its own source of computing power. It's also got certain access to other devices in the local area network through that access switch based on certain permissions that are being done on that particular device, or maybe some other server like a Windows Active Directory server that are providing access controls. Now, what separates this local area network from a wide area network is a couple things: distance and geography. Okay, wide area networks have to cover larger geographic ranges. They may need to, it's more expensive, they may need to lease telecommunications lines, they need higher data transfer rates to move. Basically, they connect local area networks together over larger geographic areas. So wide area networks are going to cover, you know, large metropolitan, regional, even national boundaries. And they could be a network of routers, a network of switches over public communications links like those provided by the telecommunications companies, for example, your Sprints and your AT&Ts and your other types. And there's different types of connectivity options. We'll look at those a little bit later on. But you can also compare a wide area network WAN to a MAN. It's a MAN, baby, like Austin Powers would say, a MAN. It's a metropolitan area network. These are typically wide area networks that span an entire city or an entire township. Often they're going to use a wireless infrastructure or fiber optic links. Again, a MAN is different than a local area network and a wide area network because it's optimized for this specific metropolitan area network to cover blocks of buildings. Often the MAN will maybe just encompass the downtown area, things like that. In cities that have large universities or medium-sized universities, you'll also hear things called CANs, or campus area network. So obviously that makes sense. Now a SAN is kind of a different entity, but it still falls into the same category because this is really getting into database processing here. A storage area network is really kind of an architecture, and it uses different technologies to attach remote computer storage devices like tape libraries, CD arrays, disk array controllers to database servers so that it optimizes, along with the operating system, this communication to the locally attached devices. Again, these are typically used in larger enterprises to do things like data storage, data mining, clustering, file system storage, things like that. Yes, it's true, Pan is the mythological Greek god of shepherds and flocks and mountain wild animals, hunting and rustic music, but we're talking about personal area networks here. A PAN is typically a wireless phenomenon. It's a wireless network environment. And they're also called piconets or piconets. Bluetooth technology, Bluetooth PANs are popular, where you can have up to 8 active devices in a master-slave relationship with each other. Up to 255 devices can be in this PicoNet in parked mode. And so these personal area networks typically have a range of about 10 meters, although you're starting to see them get up to 100 meters. This is an emerging technology. And just remember that PAN stands for Personal Area Network, and it relates to wireless small network. So we're going to focus for the CISA exam, we're going to focus on really on local area networking and wide area networking. Now, LANs are typically smaller geographic area, fewer nodes. You'll see them often using switched Ethernet technology, 802.3 or wireless 802.11. And these are, of course, are IEEE, the organization IEEE. These are IEEE standards. You can combine switches together and create trunks between them to create a fast backbone for your medium-sized to enterprise organization. Now, when it comes to our choice for physical media, another taxonomy or classification really comes into three categories for the LAN. You can see these Ethernet cables here, and typically we use Ethernet category 5E or category 6, which can support 10, 100, or 1000 megabit per second based on the implementation. Or you might see fiber technology, F-I-B-R-E, fiber technology, which can support longer distances and much higher bandwidths, or it might be a wireless local area network. And you can see here we're using a wireless access point with a variety of different radio frequencies or specifications to support multiple devices in a wireless local area network. Now, choosing the right kind of media, whether it be category 6 twisted pair cable that we just saw or fiber optic cable is one thing, but choosing the topology of your or design of your network is another thing. And what we see here are three different types of topologies. We've got a bus topology, we have a ring topology, and we have a star topology. Now, realize that, let's just use star for example. In a star topology, we have a central point here where all of the devices are connected to get access, and they're contending for access from that central point. In this case, we have what we would call an Ethernet switch. Now, although physically this looks like a star topology over here, you've got a central device called a multiple access unit, which is a special kind of token ring hub. This is still being, data is being, or access to the medium is still being contended as a token gets passed around this ring. So it looks physically like a star, but logically it operates as a ring. And this can be a ring that uses Ethernet cable, or we could use fiber optics to create what's called a FIDI ring, which is very popular to use in high-speed backbones. Now, this, of course, this bus topology and the old kind of coaxial cable, older Ethernet, where you'd have a device that would tap into this cable and you're all contending for the available bandwidth. This bus topology has really kind of gone away in the wired network environment. You still technically see a bus environment in a wireless, because every wireless device is contending and they can only transmit one at a time. So the bus topology has kind of gone by the wayside and been replaced with this switch topology, where it's a physical star and a logical star, where all these devices, and there's really what we call a backplane on this switch. There's technology that has the ability to create what we call full duplex connectivity with these Ethernet cables as these devices are connected to the switch. So there's three main topologies: bus, star, and ring. From a practical standpoint, you'll see rings used in a fiber backbone environment. Typically, we see the star topology in most of our local area networking environments. And bus, we don't see much more in local area networks in a wired sense, but technically from a wireless standpoint, we're still kind of using a shared bus technology. However, the bus in that case isn't a cable like a big coax Ethernet cable, it's actually the airwaves. Let's look at the prevailing WAN technology options. We've got, first of all, the most ubiquitous, which is packet switched. Packet switching networks are, we find these in what we call frame relay. I'll just put FR, the very popular frame relay technology. Maybe X25, which is still used in international environments. This is where you're transporting packets over a shared either point-to-point link where you've got one router connecting to another router, or over in this packet switch network could be the internet, it can be telcos, it can be ISPs, or it can be a point-to-multipoint link over this carrier network. The device at your headquarters here and the devices at your remote offices and branch offices, these devices are responsible for doing the routing between these devices and through that network. These packets are variable length and they're transmitted typically over what are called PVCs, permanent virtual circuits, or sometimes SVCs, switched virtual circuits. The advantages of this solution are it's pretty cost effective. Disadvantages, a little bit more complex to configure this multi-point scenario, and you're dealing with shared media across the link. Now the circuit switched option, this is a dedicated circuit path. This is typically offered by the telecommunications companies. I'll put telco. A switched circuit path between the endpoints. A good example of a circuit switch connection is a dial-up connection, okay, ISDN. So ISDN and dial-up are circuit switched options. Both of these use point-to-point protocol to set up, send data, tear down, some authentication, some compression, those types of things are provided by that protocol. This is also an inexpensive option. The disadvantages are you have to set up the call. There's a call setup process. Just like you're making a phone call from your phone, you got to dial a number and set the call up and tear it down. Plus, this is a good solution for, let's say, lower bandwidths, maybe out in rural areas or suburban areas that haven't quite yet got cable or DSL or satellite. You'll see 28 kilobit per second to, about 144 kilobit per second as far as the bandwidth goes. A leased line option is the most secure option, but it's also the most expensive option. Protocols used in leased line scenarios are also PPP, but you'll see HDLC protocol. These are layer 2 OSI layer 2 protocols, by the way. PPP, HDLC, ISDN. Lease line is a point-to-point connection between two computers, two local area networks, two routers. Disadvantages are this is a really expensive solution. This is really kind of a virtual private network, a leased line between the headquarters and remote offices or other areas of the metropolitan area, region, or campus, either internationally. Cell relay is kind of like packet switching, okay? Cell relay is a solution that uses fixed length cells, okay? Fixed length cells instead of the variable length packets that we see in a packet switch network. The data is divided up into these fixed length cells, and then it's transported across VCs or virtual circuits. Cell relay is a really good option for high bandwidth scenarios, voice, and combining voice and data, voice, video, data. There is extra overhead with cell relay, and the most common cell relay technology is ATM, asynchronous transfer mode. Now, one of the most common devices used in WAN technology is a modem, or certain devices will use what's called a CSU, DSU. These are modem type technologies. DCE devices, data communication equipment devices, that make it possible to use the analog phone lines as digital transmission media. So modems are convert the digital signals into analog data signals and reconvert analog data back to digital. That's why they're called modulators, demodulators, modems. Now the main job of a modem at both ends is to maintain a synchronization of the session, of the circuit, of the channel, so that the receiving device knows when each byte, when each 8 bits starts and ends. Now realize this brings in two new terms for us. A lot of these devices will use what's called synchronous transmission, A lot of these will use asynchronous transmission. Synchronous transmission means that, well, there's a clocking mechanism, sync, it's in sync. So the bits are transmitted without any interruption at a constant speed, and the sending modem will use certain characters to say this is starting the data block. So it synchronizes with the receiving device. So in a sync environment, the sending device synchronizes with the sending device. Asynchronous, however, is simpler but less efficient because there is no synchronicity between the transmitting and receiving device. They have to use what's called a start bit and a stop bit after each data byte. It's not this constant speed flow without any interruption. Asynchronous is good for, let's say, character mode transmissions, like maybe from a terminal or a console session. Now, to continue our wide area network taxonomy, I have mentioned protocols like point-to-point protocol, X25, frame relay, ISDN, ATM. Let's go ahead and talk about some of these WAN technologies in a little bit greater detail. Point-to-point protocol, or PPP, typically connects two nodes or two endpoints, and almost every vendor has their own implementation of PPP. It can use serial cables, cellular telephones, fiber optic links, phone lines, trunk lines to connect two different endpoints. Most ISPs use PPP for customer dial-up access to the internet. Also, with the popularity of DSL, you start to see point-to-point protocol over Ethernet, PPPoE, and point-to-point protocol over ATM, PPPoA. Frame relay is an efficient and inexpensive way to relay frames to one or many destinations in a point-to-point or multi-point environment. Many network providers use frame relay to encapsulate voice and data between local area networks over wide area networks. With the advent of multi-protocol label switching that we'll look at here in a second, virtual private networks, and broadband services like cable and DSL, frame relay is starting to subside. Frame relay is used at layer 2 of the OSI model and uses either PVC's permanent virtual circuits or switched virtual circuit to form logical end-to-end links over a physical network. Frame relay began as kind of a stripped-down version of the X25 protocol. ISDN is technically a physical OSI physical layer 1 technology. It stands for Integrated Services Digital Network, and it's an integrated service in the sense that it has the ability to deliver at least two simultaneous connections, any combination of data, voice, and video or fax over a single line. You can attach multiple devices to the line as needed. So for many years, ISDN's been a complete communications service at much higher data rates for businesses and small office and home offices. Now it's digital in the sense it's purely digital transmissions, as opposed to the plain old telephone service, which uses an analog telephone modem for access to the internet. ISDN transmits data digitally with none of the limitations of analog transmissions. And then, of course, it's a network. It's not simply a point-to-point solution like a leased line. ISDN networks extend from the local telephone exchange to remote users and businesses and include all the communications and switching equipment in between. It's very common to find a company using frame relay, ATM, or MPLS, that we're going to talk about here in a second, is their main connectivity to their provider, and still using ISDN as a failover or a backup line in case their main circuits come down. ATM stands for asynchronous transfer mode. This is an OSI layer 2 technology. It's a cell relay circuit switching network, and it encodes data traffic into small fixed size cells. ATM networks run over SONET or synchronous optical networking layer 1 links, which sets it apart from packet switch networks like IP over Ethernet, which use variable sized packets known as frames. ATM is a very successful WAN technology, and many telecommunications companies and IFPs implement ATM at the core of their wide area networks. Also, many DSL, as we'll look at here in a second, ADSL specifically, implementations use ATM. MPLS is very interesting. It stands for multi-protocol label switching, And it's a technology that has the same goals as frame relay and ATM, but it's now rapidly replacing frame relay and ATM in the marketplace because it's more suitable for current and future technology needs. It's a data transport mechanism that emulates some of the properties of a circuit switch network over a packet switch network. And MPLS actually operates at OSI layer 2 and layer 3, the data link and network layer, so it's often referred to as a layer 2.5 protocol. It basically unifies data carrying services for both circuit-based and packet switch clients in a datagram service model. It can carry all different types of traffics. That's why it's called multi-protocol. It can carry IP packets, native ATM, it can carry Ethernet frames, it can carry SONET or traffic over optical networks. It's very flexible, very powerful. DSL or digital subscriber line is a very important technology for small office, home offices, regional offices, and branch offices to use the internet to get high-speed connectivity. The A in ADSL stands for asymmetric, which means you have faster download speeds and slower upload speeds. It's asymmetric. Typically, DSL connections used in combination with a virtual private network from a remote office, a branch office, a small office, home office, to a headquarters. Also, you can get 256K to 24 megabit per second type of bandwidths on DSL. And it's quite likely that you're using a DSL modem right now to access the internet. And a DSL modem, or perhaps the last category here of WAN technology used from the small office, home office, branch office, and that's cable technology. Now remember, DSL is a OSI layer 1 technology, and for its data link, it typically uses PPPoE, PPP over Ethernet, or PPPoA, PPP over ATM for its data link layer 2 connectivity. And last but not least is cable. Using the internet over your cable TV provider. Let's say you're using someone like Cox.net. There's a lot of these companies, Broadcom, and so on. What we're really talking about here is a specification called DOCSIS, D-O-C-S-I-S. This is the international standard that was developed by Cable Labs, and it's what all of the cable companies use to provide this asymmetric high-speed internet communication. Asymmetric in the sense that the downstream is faster than the upstream. Now, cable is really a layer 1 and layer 2 technology, so DOCSIS provides specifications for the actual physical and for the data link as well. Your transfer rates are going to depend upon the version of DOCSIS you're using and what your cable company provides. As I mentioned, this is a common solution for the small office, home office, small to medium-sized business, branch office, remote office. There's your WAN technologies. Now, we've defined local area networks and the technologies and wide area networks and the technologies, and we've also applied those to the different layers of the OSI model. But nowadays, one of the most important factors that connects components in a local area network to a wide area network, or multiple aspects of a wide area network together, is the virtual private network, the extension of your corporate headquarters to remote sites and remote users. It's a private communication link that's established over an untrusted network. And typically, the untrusted network will be either the global internet or it would be the extensive network of a service provider and its partners. Now, the components, the physical components that make up a virtual private network are varied. As a matter of fact, almost every network-enabled device that you could purchase nowadays has some type of VPN termination capability. Basically anything that's been manufactured in the last 5 years, whether it be a dedicated VPN concentrator or a router that's VPN capable, a multi-layer switch that has modular VPN capabilities. Obviously, a dedicated security appliance like a Cisco PIX firewall or a concentrator or an ASA adaptive security appliance device will have that as well. But wireless router, if you get a cable router or a DSL router for your home, it'll typically have VPN capabilities built into it. There's encryption, wireless gateways, and dedicated security servers that have multiple network interface cards in them. And of course, you've got the VPN client itself, which can be a hardware remote device at a small office, home office, or branch office, or it could be a software client from one of many vendors that's installed on a PC or a workstation or a laptop or a handheld device like a PDA device. Now, there's two general categories of virtual private networks. You've got remote access, which typically connect a headquarters or some type of head-end office to remote access users. And these are access users that are in teleworkers, small offices, home offices. They're dialing in from kiosks, from hotel rooms, from the airport, remote access users. They have a dynamic state. Typically, remote access users are going to have some type of software VPN client installed on their device. Then you have site-to-site VPNs, which are basically between two main head ends, maybe a headquarters of one company to a headquarters of another, maybe from a government office to a research facility or a university, or maybe it's a main corporate site to a bunch of remote offices or branch offices that also have VPN termination devices like VPN-enabled routers, multi-layer switches, security appliances, or dedicated VPN concentrators. A VPN solution, as far as the OSI model goes, is a layer 3 through layer 7 solution. So the network layer all the way through the application layer, and it's what we call an overlay. It lays on top of the network infrastructure or network layer physical and data link. So a VPN typically will lay on top of whatever network infrastructure you have in place for your organization, whether it be over frame relay or ATM or SONET, some type of technology like that. And rarely does a VPN deal with the data link layer or the layer 2 functionality. VPNs can be used in remote access scenarios from one site to another site. A VPN can be used in your corporate intranet to encrypt traffic or authenticate devices on your intranet, or it can be used in an extranet between your corporate office and maybe one of your partners, one of your big customers, one of your vendors. It's a cost-effective, secure extension of the corporate LAN for a wide variety of users, getting corporate access from remote users and teleworkers. It can also be used to secure your supply chain management with your vendors or strategic partners. ISPs provide VPN services to give value-added services to their customers. It allows you to leverage inexpensive, fast technologies to get secure communications, authentication, authorization, and encryption or confidentiality over a public untrusted network. The final topic we're going to cover in this Nugget movie and this group of 3 Nugget movies is wireless technology, which is such an emerging and fast-growing area that as an auditor, you need to kind of have your fingers on the pulse of what's going on, because many organizations will add wireless implementations without really thinking through the process and the security ramifications of wireless. This is one of my favorite new devices that I use in my small office, home office. It's a Netgear VPN firewall .11g wireless switch, and it's such a killer device. It's got 8 hardwired switch ports, plus it's a wireless access point and a router, as well as a VPN firewall. And it's not that expensive. It's under $200. I think I got mine on eBay. I love this because most of the commercial devices you find out there have maybe 4 ports on them. I need more than 4 ports to connect my small office, home office, local area network, plus I've got at least 3 wireless devices that need access. And so I'll connect this through a perimeter router that actually goes to another wireless technology, which is actually a proprietary Motorola wireless. The tower is about a mile away from here. So I get, again, it's asymmetric, so of course I can download faster than I upload, but I'm very pleased with my wireless technology. Let's talk about the different specifications of wireless, because as a CISA, you're going to have to approach this from a IEEE standard. So let's take a look at the specifications here. Now, interestingly enough, I actually use a wireless local area network, of course, behind that Netgear router. And then, as I mentioned, I have a Motorola proprietary wireless solution between my home and a tower. So I'm using wireless local area networking and wireless wide area networking. So I'm using both types of wireless technology. But it all began with the original 802.11 standard, which is actually called Legacy. This was released in 1997. This had data rates of 1 and 2 megabit per second, which really isn't that good a bandwidth, and it's even less than that when you consider that wireless is a contention-based environment. It works at half duplex. Every device, only one device at a time, can transmit on the wireless service set. So you only get about 50% of that bandwidth anyway. So because of the limitations, 802.11 rapidly became replaced by the very popular and still prevalent 802.11b, which has a range of about 164 feet or 50 meters and a maximum throughput of 11 megabit per second. But again, theoretically, you're going to get about 5 to 6 megabit per second because of contention based. It uses what's called CSMA-CA. It operates in the 2.4 gigahertz spectrum. Now in 1999, the .11a standard was standardized, but it didn't start shipping on devices till about 2001. 11a uses a 5 gigahertz band, and it operates at a raw speed of up to 54 megabits per second, so you get much higher bandwidth. Typically, though, it'll operate somewhere around 20 megabits per second. And as you add more devices to the area, and as you get farther away, it will automatically decrease from 54 down to 48, down to 36. So it automatically, as you add more devices, again, the more devices you have, the less ultimate bandwidth there is, and the farther away the device gets from the access point, it's going to automatically kind of fall back to lower rates, like 18, 16, all the way down to 6 megabit per second if it has to. If you remember, my Netgear router was in a .11g, 802.11g. It actually will operate, though, with 11a, 11b, and 11g, a very flexible device. But 11g was ratified in 2003, so it's only been a few years, and this is really a quickly emerging. 11b has been the most common for quite a while, but 11g is starting to become the kind of the de facto standard, which works in the 2.4 gigahertz range, the same as .11b, but it gives you those .11a speeds, okay, up to 54 megabit per second. But again, the net throughput, because of contention, is only about 24.7 megabit per second. But 11G is fully backward compatible with 11B. So if you get a 11G access point from Cisco or Netgear or Linksys or whoever, it will fall back and talk to 11B devices. 11N could stand for next generation. Actually, on the box it'll say that, but that's not really what it means. It just means that was the next available letter in the .11 specification. But .11n came around in 2004, and you're starting to see these on the shelves out there. This is a new standard for wireless LANs, real speeds of about 100 megabit per second. So that's like fast Ethernet, all the way up to 250 megabit per second. So it's 5 times faster than 11B and 11G standards. And it uses some techniques called multiple input, multiple output on multiple antennas to make this possible. The standard's already been completed and ratified. B, G, and N are the ones that you're going to see commercially. But 11I has to do with security. And 11I is RSNA. And this is the robust security network. And this is to provide real security, all the way from confidentiality to integrity to availability, full-blown security for .11. Realize that we really didn't have that great of security for the first few years. The original standard was called WEP, which is wired equivalent privacy, and it really wasn't. It wasn't equivalent to a wired network. It actually had some weak encryption and weak mechanisms in place. WEP was replaced by WPA, which was kind of an interim solution until .11i, which added some extra features like TKIP and other mechanisms, other stronger mechanisms to get you better security. What you'll see now when you go out and purchase a device, you may see WPA2. WPA2 is the same thing as 802.11i initiative, or RSN or RSNA. That's the full-blown security solution that provides strong encryption with the AES encryption technique, and advanced key distribution schemes. In Part 3 of IT Service Delivery and Support, we covered information security network infrastructures. Looking at the basic taxonomy or classifications, we applied these things to the OSI model, the 7-layer model. We discovered LANs and WANs and different technologies applied to local area networks and wide area networks. We discussed virtual private networks, and then finally looked at the emerging wireless networking solution. I hope this CBT Nugget's been informative for you. I want to thank you for viewing. We'll see you in the next Nugget movie.